Hi Calculus student, this video is for chapter 5.2 part 2. Continue with definite integral. We said to calculate definite integral, which is actually a more relaxed version of finding area. We say is still a Riemann sum of limit n approaches infinity. It means you cut the function into a small rectangle, n small rectangle, but you cut a lot of them. And each rectangle's height is f of xi times delta x. So in the last videos, I talked about how to do limit of the really simple function x squared from 0 to 2. I want to do another one, which is from 1 to 2 of this function 4 minus x squared dx. 4 minus x squared is a upside down function, parabola, right? So I just want to know what is the area between 1 and 2. Okay, so I think theoretically that would be like that, right? Then we wanted to just do this part. So what is the area? So it is not a circle, it's not something, so we'll just do limit. So what is the definition of this? We say if I have AB, f of x dx, this is a notation of doing a limit of a lot of rectangles up to infinity, that many, and then I'm adding all those rectangles together from I equal to 1 to n, and I do f of xi star, which is the right hand sum, and then delta x. So in this particular case, my delta x is, what's my intervals from, this is a 1, this is b 2, so it's 2 minus 1 over n for every instance of n. And then my f of well, my xi would be what? Not f of xi. Let's erase this. Because I start from 1, right? Start from 1, so xi would be 1 add delta xi, delta x times I. So that means xi is 1 plus, let's do 1 over n, right? 1 over ni. 1 over ni, so it'll be 1 plus I over n. And in here my f of xi would be f of 1 plus I over n would equal to what? So let's see, it is 4 minus x squared would equal to 4 minus 1 plus I over n squared, right? Because this is the input. So technically it was equal to 4 minus 1 minus 2I over n minus I squared over n. So for every time I find the heights of the each rectangle, it would be this one. So this is 3. So 3 minus this. So I'm going to do the limit now. So the definite integral would be equal to limit n approaches infinity. So sigma I equal to 1 to n. F of xi, we expand it. So it will be 3 minus 2I over n minus I squared over n times delta x, which is 1 over n, right? This is here we have delta x. And then 1 over n is not part of I, so I can move it out. So I would write limit n approaches infinity, 1 over n. I still do this notation, y equal to 1 to n, 3 minus 2I over n minus I squared over n. Now I can plug in, right? Because I know that this limit to n I. Maybe I could expand one more to make it easier. It's very messy. So I expand it one by one. I equal to 1 to n 3 minus 2 over n. So maybe I'll just do a big parenthesis here. Sigma I equal to 1 to n I. So this one I can use the formula to substitute. This is I. And then sigma I equal to 1 to n I square. Do I have an n square at the bottom? Oh, I have an n square, so I should say 1 over n square. And then this would equal to what? Limit n approaches infinity. I should actually do it in notes. This is too small. 1 over n. So there's 3n, right? 3n minus 2 over n. What is sigma I? Is n plus 1 over 2. I minus, this is n squared, 1 over n squared. What is sigma I squared? Is n plus 1. Do you still remember? N plus 1, 2n plus 1 over 6. And that is all the limits. So no more sigma. We just do the notation to the limit, right? So now I'm going to distribute the 1 over n back. Okay, so use some of the space here. So that would equal to, so I still need to do limit. N approaches infinity. And I would have 3n times n would be 3. Okay, minus. And then this would be n squared. So the 2 and 2 cancel. I have n squared plus something. The bottom is n squared, right? Minus the bottom is 1 over n3, so 6n cubed, right? Because when you distribute, the top is 2n cubed plus something. Why don't I write those? Because when I do the limit, they don't matter. The matter of a rational function is the leading coefficient. So once you do the limit, this become equal to 3 minus 1 minus 1/3. So 3 minus 1 minus 1/3 is 5 over 3. So there I do the actual area of from 1 to 2, 4 minus x squared by doing the limit and using the sigma formula. Okay, so you can see that it's really difficult, and especially we have little space. So the second part of this would be, maybe I should do a third video where we'll do this by geometric formula. Yeah, maybe I'll just stop here and then do the third videos that only evaluate definite integral by geometric formula. Okay, I'm gonna stop.